This video reviews set theory and probability. So we're going to determine and use formulas including the addition principle to find unions of two and also the union of three sets. So first of all, let's review our terminology. Our U means union, which is or, one or the other. Our upside down U means intersection, which means and. So we need both. Now, if we have mutually exclusive events, it means they don't overlap. They're completely separate from each other. One event does not impact the other event. And if you look at it in terms of a Venn diagram, they're completely separate sets with no overlap, as you can see in the diagram here. So for this example, consider the integers from 1 to 12 inclusive. Complete the Venn diagram for the integers. For these integers, they're either even or odd. They can't be both. So when we go through, we go, okay, 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even, and we keep going, putting our numbers into our sets. So you can see that these are discrete. They're mutually exclusive. They're completely separate. There's no overlap. You can't have both. Okay? Now, if A is a finite set, meaning that it has a set number of elements, then we can denote the number in the set as n of A, or A within straight brackets, which, as you will learn as we go through in Specialist, that also means magnitude. So if you think about it that way, it's size so it's the number in the set. So if I wanted to look at how many even numbers there were in our set, I could write it like that. And we have 6 numbers. The size of it contains 6 things. Now, when we're looking at Venn diagrams, our intersection means and. We need both things. So here we have set A and B. There's an overlap. They're not mutually exclusive. So A and B, or A intersects B, is what's in the middle, that overlap. Now the complement is everything but something. So if I want the complement of A, I want everything but A. So you can see that with the shading, where I've shaded everything but the set of A. So that's the complement, and we denote that with the dash. Now a null or empty set is denoted by a circle with a line through it. Now if I looked at the set A and B here, where these are mutually exclusive, so that means there's no overlap, I can say the number in A intersects B is 0. There's nothing in it because there's no overlap. They're mutually exclusive events. If I wanted the number in A union B, remembering union is or, then it's the number in A plus the number in B. Now that's known as our addition principle. When I'm looking at the union, which is or A or B, A union B, then in regards to my sets, I have the number in A, I have the number in B. But if I've done that, what you should see is you've added the intersection twice. Okay, so you've essentially added that twice, so we need to take it away. So we take away the number in A intersects B. This is known as the inclusion-exclusion principle for two sets. So let's look at some examples. Each of the 25 students in a Year 11 class studies physics or chemistry. Of these students, 15 study physics and 18 study chemistry. Determine how many students study both subjects. So if I'm drawing a Venn diagram for this, okay, so let's go let physics equal P and chemistry equals C. We know there are 25 students, so the number in both is 25. Now it also says physics or chemistry, so we've got P, we've got C. Now of these students, 15 students study physics and 18 study chemistry. Now 15 plus 18 equals 33. That's greater than 25. So there's overlap. Now the overlap is going to be 33 minus 25, which is 8. So we put that 8 in the middle. Now chemistry was 18, so that means I need 10 here. Physics was 15, so that means I need another 7 there. Now, I want to determine how many students study both subjects. And you can see that with the Venn diagram as being 8. So the number in P intersects C is 8. Now, if instead of drawing a Venn diagram, we want to use set theory, we can go P union C. The number in both is going to be, one or the other, is going to be P plus C minus P intersects C. Now we know there are 25 students. We know that 15 study physics, 18 study chemistry, and then we need to work out what the intersection is. So we have 25 equals 33 minus P intersects C. So P intersects C is going to be 33 minus 25, which is 8. So therefore, 8 students study physics and chemistry. So 2 ways of solving this problem. Method 1, drawing a Venn diagram. Method 2, using our inclusion-exclusion principle for 2 sets. Now our next example, a bag contains 100 balls labelled from 1 to 100. Determine how many ways can a ball be chosen that is a multiple of 2 or 5. Now note the or. So what I want to find is the union. So let A be multiples of 2 and B be multiples of 5. Now if I want to know how many multiples of 2 there are from 1 to 100, that's half of them. So 100 divided by 2, which is 50. Now how do I work out how many multiples of 5 there are? Well, that's 100 divided by 5, which is 20. So now if I use my inclusion and exclusion principles, now to work out A intersects B, that's multiple of 2 and 5, which means multiple of 10. So that's going to equal 100 divided by 10, which is 10. So my inclusion-exclusion principle is A union B is the number in A plus the number in B minus A intersects B, so in both. Plug in the information I've got, 50 plus 20 minus 10, which is 60. So I have 60 ways to select a ball that is a multiple of 2 or 5. Next, a hand of 5 cards is dealt from a deck of 52 cards. Determine how many hands contain exactly 2 clubs. So 52 cards, and there's 13 of each suit. So number of hands with 2 clubs means from 13 clubs I want to select 2, and then from the 39 other cards I need to select the other 3. That's 712,842. Therefore, 712,842 hands will have 2 clubs. Next, 3 spades. So, from my 13 spades, I want to select 3. And from my 39 other cards, I need to select 2. Use your calculator. 211,926. Part C, 2 clubs and 3 spades. Note there's an and, so that's multiply. So that's going to equal 13C2 times 13C3, which is 22,308. 2 clubs or 3 spades. Now this one's a little bit different. If I let A equal two clubs and B equal 3 spades, then we worked out in part A that the number for A is 712,842. We worked out in part B that the number with 3 spades is 211,926. And in part C, we worked out that A intersects B is 22,308. So using our inclusion-exclusion principle, we have, because 2 clubs or 3 spades is A union B, so the number in A union B is going to be the number in A plus the number in B minus the number in A intersects B. So we've got 712,842 plus 211,926 minus 22,308. And that gives us 902,460. And don't forget your therefore statements, which I have. So I've gone through and added all my therefore statements.